Good evening. Good evening. My name is Pat Naidoo, and I'm going to be your moderator for this evening. Welcome to all our attendees. Before we get started, just a few housekeeping issues, and let's go through this slowly. Firstly, attendees are reminded to switch the volume on their device. Ensure you have a stable internet connection. This will give you a good streaming and your audio will run smoothly. Attendees are requested to ask questions via the questions panel, which is located on the GoToWebinar control panel. By default, the control panel is located on the right-hand side of your screen. Right, the chat function is reserved for webinar organizers and panelists. Attendees will not be able to use the chat function, but you can ask questions using the control panel and the questions module on the control panel. A recording of the presentation will be made available on the SAIEE YouTube channel, SAIEE TV. The recording will also be made available on the SAIEE website under the events drop-down menu in the section, past events and webinars. This page is updated regularly. So ensure you check back as often as possible for new uploads and subscribe to your YouTube channel for more uploads. Right, a certificate of attendance will be issued a few weeks after this webinar once we've got the CPD validation number from EXA. Right, so thank you, colleagues, and thank you for joining us this evening. We have an excellent team ready to share with you their knowledge, their wisdom, their experience. And we'll start first with the agenda, and I'll get the agenda up, the program, there we are. I'm your moderator for this evening. We'll have a welcome from the chair of the South African Institute of Electrical Engineers Power and Energy section, that is Engineer Ntombela. We'll have a co-host address from the president of SAIEE, Dr. Rob Stephen, followed by a co-host address from the chief engineer of the Southern African Power Pool, it's Alison Chikova, and thereafter we'll follow through with our keynote address from the IEEE president-elect, Professor Rahman. We'll take question and answers towards the end, and then we'll close by around 2000 hours. So thank you for joining us today, and without further delay, let's get started with the proceedings. As advised, I'm your moderator for the evening, and I'll be picking up your questions as you load them on the control panel, and I'll pass the questions over to my colleagues, and they will give you the response. If we don't get through all the questions, we'll post the balance of the questions on the chat at the SAIEE TV, and you'll be able to follow up on all the responses. Firstly, we have the chairperson of the SAIEE Power and Energy section, who will formally welcome you. And her bio reads as follows. You could see it on the screen, but let me read it also for you. Engineer Ntombela is part of the family at SAIEE and Eskom. She leads the plant refurbishment team at Eskom and is currently tasked to ensure continuous improvement of plant to comply with current technological practices, safety standards, and desired operating performance. She is certainly a part of the asset management team at Eskom and focused on extending the useful life of all plant and equipment. Sichibili is the current chairperson of the section, and she is also a member of council. She has a BSc degree in electrical and electronic engineering from the University of Johannesburg. Right, I'm going to let her say a few words, and then we'll take it from there. Over to you, ma'am.
Thank you, Prof Naidoo. Good evening, ladies and gentlemen. My name is Tebile Ntombela. I currently serve in the South African Institute of Electrical Engineers as the Power and Energy Section Chair. I would like to take this opportunity to welcome all attendees to this exciting webinar, which is brought to you by SAIEE Power and Energy Section in collaboration with IEEE, South African Power Pool, and SAIEE. Today, we will be looking at the role of the smart grid in facilitating the integration of the renewables. Our focus will be on the environmental sustainability and energy security. I'm sure that we can agree that smart grids can play a crucial role in transition to the sustainable energy. Therefore, it is important that we continue to have this conversation around this topic. Today, we are honored to have a dynamic team of presenters, which I would like to acknowledge. A big thank you to Mr. Alison Chikova, Dr. Rahman, Dr. Rob Stephen. We appreciate the time that you took out from your busy schedules to come and enlighten us today. To Minx and the team working behind the scene, thank you for your dedication and making sure that we are able to bring these webinars to life. And I'd like to say Happy Women's Month to all the attendees that are female today. Without further ado, I'd like to hand over back to our moderator. Thank you, Prof Naidoo, over to you. Thank you.
Thank you, ma'am. Colleagues, let me introduce Dr. Rob Stephen, the president of SAIEE, who will be our first co-host presenter. Rob Stephen was born in Johannesburg, South Africa. He holds BSc, MSc, MBA degrees, as well as a PhD in overhead line design. He retired from Eskom on 31st January 2020, where he held the position of Master Specialist in the technology group responsible for distribution and transmission technologies of all voltages covering both AC and DC. He was responsible for the smart grid strategy for Eskom. He is past chairman of SAIEE Study Committee B2 on overhead lines and has held positions in SAIEE of special reporter and working group chairman. Rob has authored over 100 technical papers. He was elected international president of SAIEE in 2016. He is a fellow of the South African Institute of Electrical Engineers and received the President's Award in 2016. He has held positions of the chairman of SAIEE Power and Energy Section and chairman of the KZN chapter. He is also the honorary vice president of the South African Institute of Electrical Engineers. So welcome to Dr. Rob Stevens. I'm going to hand you the presentation. Thank you, Dr. Rob. Over to you.
Thank you. Can you see the screen? What I would like to do this evening is just give you a very brief overview as an introduction to
We can see you.
Thank you. As an introduction to Prof Rahman's talk on smart grid, and this really covers the future grid technologies. Let me just get the. You need to share the screen. If I can get my presentation up, Pat. Thank you. What I would like to cover then is the future grid technology trends, which will actually lead into the talk by Dr. Rahman. Just to give you an update, SAIEE has been working on future grid technologies. Well, it's part of their normal work, but they have now produced a green book on future grid, which will be available this month. And it covers future grid trends in all of the 16 areas that SAIEE are working in. Just to give you a bit of an idea of the historical to emerging trends that we have in the grids today. The historical one, of course, rotational inertia, dispatchable generation, predictable loads, and static T&D infrastructure. The emerging, which is actually existing in many parts of the world, a very reduced stability, faster dynamics. We've got stochastic generation coming from all areas. The customers or consumers are now prosumers. They produce energy and ancillary services, as well as consuming electricity. There's an adaptive T&D infrastructure, and there's the other thing, of course, is that you've got very low inertia systems. And what does that require? It requires these areas down here, which are sensors, faster than real-time analysis, precise control, resilient systems, and PMU measurements. Just looking, this is the PAS system, which was mainly unidirectional. So in other words, you had the generation pass to transmission to distribution to the customer. The evolution that we're seeing now is that your generation can come in at any point, at the customer point, at distribution and transmission. Power flow is also from any point to any point. In other words, you could get customer generation flowing into the distribution network, which flows into the transmission network, which affects your transformer settings, protection settings, etc. Not only that, is the generation on the customer and distribution and transmission now not dispatchable, but it's also random, stochastic, and can affect the operation of the network. So what we've looked at here is that these are 10 areas that, and I won't go into these now, but these are areas that you need to actually be aware of, and they need to be addressed simultaneously if you want a sustainable grid. And the one we need to look at here, really on the smart grid side, is more the active distribution networks, but also that affects massive exchange of information, power electronics, and of course storage. Looking at the future grid, future life on Earth, we see increased use of renewables, low carbon, low cost, low impact, the increased need of electricity in modern life, and the issue of reliable supply from solar and wind for future grids. And then, of course, renewable energy supply systems. And then based on the premise, can one country make its expansion plan without linking to others? And there is, of course, work by GuideCo from the State Grid of China looking at intercontinental connections with a universal grid. The aim being that, of course, the wind and the sun are always present somewhere on the Earth. So if we can take that energy and transmit it to other areas where they are not prevalent, we can then supply energy 24/7 at any point in the globe. So there we've got the regional interconnections, electricity-based integration planning, and then time zone to integrate new energy resources. In other words, where you've got where you've got different demands coming up in different time zone areas, you can transmit power from those that are not using it to the others. And of course, then SAIEE becomes more important in this area. Just looking at the active distribution networks, really what we're looking here is massive penetration of distributed generation units, which imposes a need for their control and organization. Here you need smart metering implementation, markets and regulation, which we don't have much in this country, is also extremely important because the effect of the markets will affect the how the distributed generation is actually implemented. Then you have new market orientation, control of distributed generators, virtual power plants, and then of course the ancillary services to provide support right up to the transmission level. And this includes fault level support, voltage support, inertia, synthetic inertia, and so on. So the distribution networks now, your smart grid, is becoming so much more than just data and customer information. It's becoming really a tool from which you can actually operate the system and integrate in renewable or inverter-based resources. Looking at your research areas here, we're looking at modeling, analysis, control, and so on. How do we actually model these active networks? Just to give you an idea so that you can understand, this is not very clear. It's a slide from EPRI, and on this side here, you've got inverter-based interconnection, which is your grid scale wind, grid scale PV, distributed PV, and distributed battery storage. What you have to operate a grid is you have to have green everywhere. And as you can see, the ones that are on the left, which is your coal, your natural gas compliance cycle, nuclear, and hydro, in fact, are those which give you the green at the moment. However, the inverter-based resources are those which give you very low-cost energy. So the aim is to try, by using technologies, storage, smart grid, to in fact enable the inverter-based interconnections on the right to become totally green. And this is really the challenge that we're facing. Just to give you an idea of how we can perhaps achieve this, where we're looking here at e-hydrogen, in other words, a green hydrogen, not the grey or black hydrogen produced from coal, but there is moves afoot now to in fact generate hydrogen from inverter-based resources, that's your solar and wind, and that is called e-hydrogen or green hydrogen. So basically we're using now, it's actually power to gas, not gas to power, but it can also be power to gas through electrolyzers. Then you've got natural gas on the grid together with heat pumps to supply heat and cold to buildings. You've got industries using hydrogen. We've got the chemical industry using generating fertilizers through to agriculture, petrochemicals, and largely onto mobility. The beauty about the hydrogen is that you can now start driving trains, planes, and large trucks with the use of hydrogen, which can be generated through inverter-based resources, so wind and solar. This also allows, of course, the curtailment that we sometimes find within the wind and solar plants to be avoided, because now you can use that excess energy to produce your hydrogen. And just as an idea or a focus going forward, there's a grand vision that they're looking at in the North Sea, and these are the people playing in that area, and you can see the names there: Tenet, Port of Rotterdam, Energinet, and GasUnie. These are large players, and they're looking at 180 gigawatt offshore wind power in the North Sea. Now they'll either use that power to generate hydrogen at the source and transmit hydrogen to the continents, or they will use the electrical energy and then convert to hydrogen in the continent at the place. So this is something which is looked at, but it's something which, if we get it right and we drop the price of the electrolyzers, we can actually realize, due to storage, etc., a totally green energy supply, which will provide you with inertia, all the attributes that is required for a stable grid. So in conclusion then, we see that inverter-based resource penetration will continue to accelerate. Loads and generators will be interchangeable, mobile, of course, through electric vehicles, and variable. Power flow will be uncertain. Markets will further distort the power, but it's a beautiful opportunity to look at business models, revenue retention, product development, and so on, including grid planning, design, operation, protection, and maintenance. So the future is definitely looking, you could say, fairly bright. Thank you. Over to you. Thanks, Pat.
Let's talk to, we have a few questions. Let's see if we can't do this at the end. Let's keep the presentations going, and then we'll take the questions towards the end. Introduce to you Alison Chikova, and I'm going to bring Alison on board. And Alison is the chief engineer responsible for planning and operations for the South Pool. He got a Master of Science degree in Electrical Power Systems of Institute in Ukraine in 1992. He worked for the Department of Energy in Zimbabwe as Energy Research and Development Officer. He then joined the National Utility of Zimbabwe Electric Supply Authority, ZESA, in 1995. He was responsible for generation planning. He's the chief engineer of the Southern African Power Pool since 2001. He's responsible for planning, system studies, and the development of transmission pricing arrangements and the ancillary services market in SAPP. He's a chartered engineer, a member of the Institution of Engineering and Technology of the UK, a member of IEEE USA. Over to Alison Chikova, who will share with us his presentation. Over to you, Alison. Thank you.
My presentation will cover the overview of SAPP and the facilitation of renewable energies and what work we are doing within the Southern African Power Pool. It will cover the key issues in terms of the facts. I'll also look at the demand and supply situation within the region, the Southern African Power Pool interconnected power system, and also look at variable renewable energy and the role of the smart grids. The vision of SAPP is to facilitate the development of a competitive electricity market within the Southern African Power Pool, giving an end user a choice of electricity supply, and ensuring that the Southern African region is a region of choice for investment by energy-intensive users, and also ensuring that the environment is not left behind. We look at ensuring sound, sustainable energy developments through economic, environmental, and social practices. We are looking at the sub-region, which is 12 countries within the Southern African Power Pool, serving 300 million people, where the available generation capacity is 56 gigawatts, and the peak demand is 57, giving us a deficit of 1.8 gigawatts. The total annual consumption for the 12 countries is close to 400 terawatt hours. We have within the Southern African Power Pool 12 countries and one national power utility per country. And also we've got other countries who have got independent power producers who are coming in, some of them coming in with various technologies, which I'll address in the following slides. In terms of the demand and supply situation, we are looking at the region where some countries are in an excess position, like in Angola. We also have an excess position. We're talking of Mozambique, but most countries are sitting in a deficit position and are actually load shedding as we speak. And as a region, the overall supply situation is that we are sitting with a power supply deficit of close to 1.8 gigawatts. In terms of the interconnected power system, 9 of the 12 countries are already interconnected. We still have to interconnect Angola, Malawi, and Tanzania, which is work in progress. And this is a priority for the Southern African Power Pool to get those 3 countries interconnected. In terms of the generation mix, still dominated by coal, and we have quite a significant amount of hydro. But what's interesting is in the last few years, there's quite a significant amount of wind that is coming up, and solar PV, and also solar CSP. You can see from the pie chart that 4.03% is coming from wind, and solar PV is giving us close to 3%, and CSP close to 1%. Looking at a snapshot up to 2022, we are seeing quite a significant amount of new wind technologies coming up, and also a lot of solar that is being planned in the various countries. But the power trading options, in terms of intermittency, we need to look at the load profile for the day in terms of what is it that we can use as the base load, giving the base demand that we are seeing at the bottom of the chart. We can also formulate by taking in bilateral contracts that are coming in, then looking also at the month ahead contract that we have within the Southern African Power Pool, week ahead, day ahead, and then at the top of the graph, we have the intraday trades. So these are the trading portfolios that can be used within the Southern African Power Pool. In terms of the evolution of the SAPP, previously we've been working on bilateral contracts. We did develop the short-term energy market in 2001, then went on to develop a post-term balancing market in 2002. The day-ahead market was conceived in 2009, then the post-day-ahead market in 2013. And at the current arrangement, we have introduced now the month ahead and the week ahead and intraday market in 2016. What we're developing now is the balancing market, the ancillary services market, and the financial markets, which are the new markets that are coming into the future. In terms of VRE projects, we are seeing a limited market access that is currently available for VRE generation. and there is need to facilitate trading within the region for VRE generation. We've also seen that most countries in the region are moving towards procurement of VRE projects using a structured manner. Most of them are using IPP programs, and we've seen that developing in most of the countries. We've also seen that most of the VRE IPP projects are underpinned by long-term power purchase agreements, mostly underpinned by utilities as off-takers. And also we've noticed that there's a lot of variance that exists within VRE PPAs across the sub-region, but there are no typical principles that are applied with a degree of consistency. It is likely that most of the VRE projects in future will be developed predominantly as IPP projects, as we see that more and more IPP projects are coming in, and more of them are developing actually the solar and wind technologies. We are seeing a new electrical power system that is coming in, where renewable energy, whether be it produced locally or sometimes far away from the grid or from the industrial centers, we are also noticing quite a lot of storage facilities that are providing electricity at all grid levels, be it at transmission level, distribution level, and also intermittency depending also on the weather pattern of the various countries. This is the smart grid that has been talked about by the previous presenter. We are also noticing that decentralization is also increasing renewable energy, and there is need to introduce the smart grid technologies to take care of this new reality. The SAPP market is ever changing, and we are seeing new solar technologies and wind that are coming in various countries. And the intermittency and the fluctuating nature of renewables needs to be addressed. We are also seeing large-scale renewable energy projects coming in, and this needs a lot of transmission investments, because we cannot only talk about the generation side, but we need to also talk about the evacuation of the power in terms of the evacuation to meet the power requirements to the customer. We're also noticing that there are a lot of solar panels that are coming up on a lot of buildings and rooftops, and this is resulting in net metering, where customers are now selling power to the power company. This is a new reality that is coming up with the new rooftop PVs that are being installed. Challenges in connecting renewables is something that we need to talk about. We are aware that solar power would be available mostly during the peak day and when the demand is low. And we also need to address issues of voltage fluctuations. We also need to look at the lifetime and the generation lifespan of the technologies in terms of the wind turbines and also the solar panels. The SAPP is carrying out a study that is looking at the impact of integrating renewable energy technologies within the Southern African power pool. And there are some key study outcomes that we have looked at in terms of what needs to be addressed going further, which looks at 8 key issues, which I will need to look at. One of the key elements is to look at cost-reflective tariffs. When you need to bring in these technologies, you need cost-reflective tariffs. We're also looking at the planning codes that needs to guide the planning of the regional transmission interconnectors in terms of strengthening the wheeling corridors. We also need to look at financial models in terms of how we rank the interconnected projects. We also need to look at how we review the SAPP operating guidelines, because we know that renewable energy technologies have got their own challenges in terms of how we look at the inertia, how we look at the accredited capacity, how we address the operating reserve, and also the VRE focusing. We need also the tools within the utilities to look at those going forward. We also need to look at how to integrate the various power pools and interconnect with the neighboring power pools and how that can be done, how we can address the generation sharing and trading options. Power purchase agreements and the various templates also need to be developed, and also training and capacity building of the system operators and the planning engineers is a priority that we need to address going forward. Renewable energy targets within the Southern African power pool, if you look at the SADC region for a period up to 2030, we're seeing about 39% on off-grid connections, looking at the generation share on electricity consumption, then about 7.5% of renewable energy is coming in on off-grid solutions. Now, the Southern African power pool is not operating in isolation. Within Africa, we've got other power pools, and the objective of the African Union is to get an integrated African interconnected system. So the power pools are going to be interconnected, starting with the interconnection with the Eastern African power pool, then going all the way to Libya, Egypt, interconnecting also Congo via the Grand Inga, and also with the West African power pool. So the objective of the smart grids in the long term will come and help within the integrated interconnections, and the interconnections of the power pools will help also to see how the various technologies and the generation mix of the power can be traded among the various power pools. This brings me to the end of the presentation in terms of how we see the smart grids integrating and also looking at the key issues of the wind and solar technologies. Over to you, Pat. This brings me to the end of the presentation. Over to you, Pat Naidoo.
Okay, thank you, Alison. I think we have lost Pat, if I'm not mistaken. I don't see him anymore here.
Yeah, okay. I think we have a technical hiccup. Let me hand over to Prof Rahman.
I'm here. Can you see my screen, everybody?
Thank you.
Is that our thanks, I am online. I'm my screen up. You access my screen. Is there links in this? What happened?
We can still see you, Dr. Rahman. You can continue.
Can you see my screen?
I can see your screen, but your presentation is not up.
Is it up now?
Not yet.
You accept it. The control is on your side. Control is on your side.
Dr. Rahman, can you maybe try and switch off your video and then try and bring in your presentation?
My screen should be visible. I can see the green light.
It's not yet
Now?
visible.
Turn video off on the orange bar, showing it's showing my screen. Maybe with the glitch, sometimes stopped. Should I log back again? Maybe think the system is still trying to find paired screen. It's stuck, it looks like.
Dr. Rahman, Minx here. Would you like to just leave the webinar and just enter again? You came on as an attendee. I've made you a presenter, but it seems it doesn't work.
Okay, then come back. Thank you.
Okay.
Okay, leaving it, come back.
Thank you. Maybe in the meantime, while we wait for Dr. Rahman, I can take the few questions that are already on the questions panel. I'll start with the first one. It's from Mike Barker. He's saying in grid interaction efficiency buildings are the next generation green buildings. Connecting them to the smart grid requires communication protocols. So the question is, which protocol will South Africa be using? Mr. Allison, would you like to answer that question, please?
Thank you for the question. It's true that a communication protocol will need to be enhanced within the various countries, and I think within the various communities, we've got the telecommunications working group within the Southern African Power Pool that is looking at various protocols that can be implemented. And we have not yet come up with a key recommendation of what can be done, but various protocols are being investigated at the moment. Thank you.
Thank you. The next question is from Kevin. His first statement is saying, thank you for a great presentation, Dr. Stephen. I'd like to hear your view on the impacts of the COVID-19 pandemic on the future of smart grids and future technologies. So that's for Dr. Rob Stephen.
Hi, yes. Interestingly, the implication of COVID up to date has been really to reduce and shift loads. In other words, what it's done is it's made the networks, especially in Europe, a lot more sensitive because the inertia has dropped. And the reason for that is that with the load dropping, the markets have favored more inverter-based resources. So you find that the resources with inertia, such as coal and gas and so on, have not been in the market, in fact, to deliver power. So this has been a big challenge. Not only that, of course, but within the operating rooms, you've got longer periods where operating staff have to remain in the control centers and things like that. But the big pickup, of course, is on the telecommunications side, where there's been an enormous increase in webinars, virtual meetings, using a number of different platforms, which wasn't done before. And the request for bandwidth and the request for increased power supply quality is also a trend that we're actually seeing. There's a number of papers coming out now on COVID and impact in a lot of the CGRE publications, which are free download. So that'll be out in the next week or so. But basically, in a nutshell, is what I've stated is what we've generally found.
Thank you. Apologies again to all attending members for the technical glitches. It looks like we have Dr. Rahman back now. Can I quickly attempt to make him a presenter? Dr. Rahman, can you hear us?
Yes, I can hear you. I'm showing my screen. Can you see my screen now?
Yes, I can see it. Perfect.
Make it full screen. Hold on a second. Is it full screen now?
Not yet,
Not
but I
yet,
can
okay.
see the slides, but they're not full screen. You just
Oh,
need to
now.
go in presentation. Yeah. Perfect. We can see your screen in full screen mode now. Thank you.
Thank you very much.